This is Unit 1, Quadratic Functions. This is Day 5. This is a review of factoring, and you're going to also see what happens when we simplify by multiplying factors together. Here we have a monomial, one term, multiplying a binomial, two terms. To simplify something like this, we're going to take the monomial and distribute it to each of the terms in the binomial. So 4x squared multiplying 3x will be 12, and then x squared times x. Remember, you'll add your exponents, that's an x to the first in there, so x to the second times x to the first is x to the third power. Now we want to do 4x squared times 3, which is going to simply be 12x squared. There is no x inside here to combine with x squared, so it stays as is. You won't always check for like terms that can be combined, but there are none here. So that's it. Moving on to part B of this example. Here we have a binomial, multiplying a binomial. You've possibly heard of FOIL, first, outer, inner, last. Typically when I teach this, I teach it by distributing, which is the same thing as FOIL. So I'll distribute the x to both the 2x and the 3. That would look like x squared plus, 2x squared plus 3x. So I just multiplied 2x and 3 by x. Now I'll go back and distribute the negative 5 to both of them. Make sure you're distributing the negative with it as well, so it'll be minus 10x and minus 15. Now here, to actually be done with the problem, I do need to combine the like terms of 3x minus 10x. So I'm going to have 2x squared minus 7x when I combine those two terms, minus 15. And that is my final answer. Really a process that you should be very familiar with after Math 1. Now we're going to be undoing the process we just did. Lots of times, particularly with quadratics, you're going to actually see what the problem looked like whenever it was factored, because factors can tell us a lot about the problem. So we're going to review that process right now. This is something that you should have covered in Math 1. The first thing that you're always going to look for is the greatest common factor. And in this case, there is a greatest common factor between 4a squared and 8a. First of all, 4 can divide into both items. Also, the variable a to the first power can divide into both of them. You'll always go with whatever the lowest exponent is as far as what can divide into them. So I'm going to establish that 4a is my greatest common factor. I'm going to divide that out now from both terms. 4a squared divided by 4a will be 1, and a squared divided by a to the first, that's where you subtract your exponents. So 2 minus 1 is a to the first power. Now, I could have just written an a there. In fact, that's probably what I prefer to see. There we go. Now, I'm going to put the plus sign, and I'm going to factor out the greatest common factor from the 8a. 8a divided by 4a. First of all, the a's are going to cancel, so you're left with 8 divided by 4 is 2. And this is my correct answer. If you want to check your answer, you can always take what you got, multiply it out by distributing, and see if you get what the original problem was. And that's a good check to do on the side. Now I know I've gotten the right answer because I ended up with what the original problem was. You also want to be careful to look and see if there's any more factoring that can happen. Each of these factors are prime factors because they can't be factored anymore. Alright, going into example 3. What we're going to do here is we're actually going to look for a greatest common factor, and as I look for one, I don't see one. There's nothing that divides into all these other than the number 1, so I'm not going to pull out a greatest common factor here. What I am going to be able to do is look for the two numbers that multiply to 6 and add to 5. Personally, I like to write the number that I'm multiplying to out to the side, which is their constant, 6, and say, alright, well 1 times 6 gives you that, 2 times 3 also gives you that. Boom, that's the pair that I'm going to use. And the reason why I'm using 2 and 3 is because that adds to 5. Now I'm going to jump back over here and set it up for being factored. X times x is what will give me x squared. And I know it needs to be plus 2 plus 3 because that multiplies to positive 6 and they add to 5. And this is my final answer. Now again, what I could do is I could actually go out to the side here, take what I got as a final answer, and multiply it out. Distribute the x to both items, so x squared plus 3x. Distribute the 2 to both items, plus 2x plus 6. And yes, this is the correct answer. because it came to what my original problem was. This is my answer over here. All right, going into example 4, again, look for a greatest common factor. There's not one. So what I'm going to do is I'm going to go ahead and write out the positive 12 over here and see what numbers will multiply to it and add to the negative 8. So 1 times 12, 2 times 6, 3 times 4. Now, as I look through there, none of those pairs will add to negative 8. Signs are important. 2 times 6 adds to 8. All right? But they need to both be negated. How did I know that? Because they need to add to a negative value. Now here's the cool thing. The negative 2 times negative 6, that's still positive 12, but now they do add to the negative 8 that I needed. So when I factor this, I'm going to set it up now. X times x will give me the x squared. Now I know that my factors are negative 2, negative 6. So my factors, my final answer is x minus 2, x minus 6. There we go. And yet another problem. This one's different because the constant value is negative. You've got to really watch out for that situation. Let's go ahead and take a look at it. I'm going to write the negative 15 down. When I do that, I know that just one of my values should be negative. So negative 1 times 15, negative 3 times 5, and I believe that's all. Well, let's actually go ahead and write it as 1 times negative 15. That would also work, and technically that is a different pair. And 3 times negative 5. All right, looking at those, I'm trying to find the pair that adds to positive 14, and actually that's the first pair I wrote down. So that's the pair I'll use. Now I'll set it up. So now I know that it needs to be minus 1 plus 15. There's my final answer. Now, if you've been watching this video and you've been stressing as to which factor should come first, realize that as an answer, it's just as good if I would have written x plus 15 times x minus 1. There is no difference at all between these two answers because of the commutative property of multiplication. Doesn't matter what order they come in. Tomorrow's lesson, it will make a difference, but we'll get there when we get there. All right, first of all, on this problem, you cannot forget to look for a greatest common factor first, and in fact there is one. The greatest common factor on this problem is 3. If you don't recognize that, it makes for a lot more work and you're much more likely to get this problem wrong. When you divide it out, you'll get r squared minus 5r, okay, minus 24 is what you'll get. Now, you're done with the first step in factoring, but it's not prime factors yet. 3 is prime, but this is not a prime factor. This can actually be factored more. Not always is that the case, but in this case it is. You need to look. So I know 3 is going to stick around, but that r squared minus 5r minus 24 can factor further. Let's take a look. We'll pull that negative 24 out to the side here and write down things that multiply to negative 24. And negative 3 times 8, and negative 4 times 6. Now, do any of those pairs add to negative 5? No, the negative 3 times 8 adds to positive 5, though, so I know it needs to be negative 3 times negative 8. That's the pair that'll add to the negative 5 inside here. Now I can bust this further apart and make it 3 times r plus 3 times r minus 8, and there's my final answer.